Babies are born knowing nothing, and this is a problem. You see, in order to make a new scientific discovery, a person must spend time learning the basics of their field of study. Science has been described as a frontier. In order to make a new discovery, you must venture greater distances. You must learn a greater amount of information to get to a point where you can make a discovery. So I ask, is it easier or harder to get to the frontier because of our abundant amount of knowledge? Is scientific progress slowing? We could analyze Nobel Prizes, which cover fields like physics and chemistry, but newer fields such as computer science are unrecognized. Plus, Nobel Prizes are like headliners in the field of science. For a more individualized unit of measure, journal impact factor, or H-index, are often used to get an idea of the impact of a paper. However, these citation analyses give equal weight to sources that are essential to the paper and sources that serve as background information. There's also the economical measure of total factor production, TFP, which over the recent decades has not seen much growth. The problem with TFP is that there's a lag between scientific discovery and the application, so discoveries of a decade ago might finally show up today, or scientific progress made today has no common use application. So, is the slow growth in TFP supported by any other measures of scientific progress? Do signs point to worse discoveries being made today? Returning to analysis via Nobel Prizes, Nobels for discoveries from the 1910s to the 1930s like X-ray crystallography, neutrons, and radioactivity, all of which have become foundational to modern science, were ranked highest in importance by scientists, where recent discoveries received the worst rankings. But another problem is that research and scientists of the past have been romanticized. We think of Mendel as a genius when his work was inspired by many thinkers before him. If the discoveries of the past are falsely held on such a high pedestal, comparison of the current research with hopes of seeing equal or exceeding greatness is futile. But what about the process of discovery? Is that getting harder? Because you need to know more stuff to make a discovery, research papers are often written with more citations and more authors, and later in life, we see bigger teams of researchers. Specialization is another way to get to frontier-level knowledge. Competency in many fields prevents expertise in one. Besides achieving high-level knowledge, the academic world creates its own barriers to making discoveries. Ever heard of publish or perish? Meaning have high citation counts, meet the paper quota. This makes it hard to be bold with new scientific ideas and takes out motivation to research for science's sake. So far it sounds like the future is all doom and gloom, but the scientific discoveries of the past do make it possible to make new discoveries. Computational scientific discovery uses various systems for fields such as engineering, astronomy, math, and chemistry to execute steps of the research process. The full advantage of this technology is limited because AI has not progressed far enough to replicate the entire research process. However, computers have been game-changing for science that requires number crunching. It's also possible for a discovery so revolutionary to be made that it renders past discoveries obsolete, making the frontier of knowledge more accessible. Researchers would not be doomed to harder and harder discoveries. AI could be the possible unparalleled discovery that will return the frontier to an approachable distance. All in all, scientific progress lacks the forward momentum it had decades ago, but we can still look forward to emerging fields such as computer science, biomedical research, robotics, and environmental science. On the other hand, maybe the perspective on what progress is should be shifted. Peter Thiel describes the world as currently going through lots of one-to-many improvements, spreading around existing innovations to get richer, but what we usually think of as innovative and scientific breakthroughs are 0-to-1 transitions, something completely new, like the mobile phone, the internal combustion engine, or the helicopter. Maybe one-to-many improvements are not so bad. We could become content knowing what we know so far. Economic growth by making the most out of what we have, rather than funneling exceeding amounts into scientific research for little return, might be the road to success.